All right, good evening. Good evening, Sean.
Good evening.
How are you doing?
I'm okay.
Good to hear, good to hear. All right, so I did get to send you the probability solution. Sorry for sending it so late. As I said, it's been a rough week, it was SBA week, so
Okay, no problem.
yeah, well, I sent it to you. So today we're going to be looking at the last two things now, right? And then we should be all set for the midterm. We're going to be looking at these two now, normal distribution and the normal approximation to the binomial distribution. This one is really easy, so it's really normal distribution we're doing. All right.
Okay.
All right, so now we're going to kick it off, normally distributed. So I don't know if sometime you will be listening to maybe geologists speak, maybe you're listening to CNN, and you're listening to when they talk about the weather report or any of those stuff, and you hear them say, this week you can expect for us to have 2,300 milligrams of rain for the week with a standard deviation of 60 milligrams. And then they might say, so the true range is going to be maybe from 2,100 milligrams to 2,500 milligrams. How did they come up with that range? All of that stems from normal distribution. So sometimes you hear people talk about this empirical rule and all of these things where they talk about 95% of the data falls within 2 standard deviations of the mean. Hear all of them lovely talking there, what them talking about in news. All of that from normal distribution. And I brought this out to say that many times people think that we don't use it in real life, but we use it every day without even knowing that we're using it. Imagine that. So beautiful, don't it?
Okay.
Yeah, so normal distribution, it is usually given by this function. You don't need to know the function. I make sure I put it in red, not required to know, because you're going to need to use the table. But if you're just curious like me and you like to put in the values of x and put it in a calculator to see if it actually gives you the same value, then you would use it. So this is the function for normal distribution, and I like to investigate the function to see if it's true. You don't need to know it because we have what we call the normal table, right?
Right.
So we won't need to look at any of that, but I like it because, for example, when a z value is 0.03, I want to, when I substitute whatever the x value is into the normal function, it should work out to give me the same probability as the normal table. So if you know the function, you don't necessarily need the table, but it's easier to just remember the table than to use the table than to remember this.
Okay.
So now there are some properties about this type of distribution that you must know. Number one is that it is bell-shaped. So the normal distribution, what it does is that the distribution of every data set, right, it has the mean as the center. The mean has to be at the center. Remember we did measures of central tendency, and we said that mean does represent the center value, right?
Right.
Typically, now, whenever you're doing normal distribution, the mean is at the center, and so you have 50% of the data that's going to be to the left of the mean, and 50% that's going to be to the right of the mean.
Okay.
50% data to the right, 50% data to the left.
Yes.
So that's why I would say it is bell-shaped. Typically, this is how it's going to shape. It's bell-shaped. It's symmetric because on the left is is
It's
pretty much
equally spread.
of what's on the right. It's literally a reflection. Are you okay? You sound a little sick.
No sinus.
Sinus. Okay, okay. All right. The range of the x values is from -infinity to infinity. And also the total area under the curve is 1, which makes sense because when you integrate it, you should get the sum of all the possibilities. And the sum of all probability, we know adds up to 1. Now, the maximum value of f of x usually occur when x is equal to its mean, and the maximum value would be given by this right here. You don't need to know it, but it's just nice to know. Just nice to know. Just something additional. You really need to know the first 4. But 5 and 6 is just additional information.
Okay.
So I don't know if you have you ever heard of Econ 1004? That is the one with mathematics in it. So they deal with like differentiation and stuff like that. Okay. All right. So this is totally useless then to you, but 5 and 6, it's nice. Don't need to know those. So now, just like binomial distribution, they had a notation that you must know. So this is the notation for normal distribution. So the notation is that x follows a normal distribution with mean mu and sigma square. Now sigma square, that is your variance. So see it here, your mean, remember E of x represent mean. So your mean is mu and var x is sigma square. Var x is sigma square, so this is the variance. In other words, it's telling us that our variance is equal to the standard deviation square. All right,
Okay.
so that's what's inside of these. Remember, we call these parameters. And when we actually have data from samples, we call them statistics. So you have to remember the difference. So remember when you're seeing like bar x comma s square, those are statistic. Whenever you're seeing mu and sigma square, that's parameter, going to the entire population. All right?
Bar X is statistics.
Yeah, and mu is for population.
Okay.
Yeah. So parameters, statistics, parameters, statistics. You know, just to always intertwine some stuff that we have been doing earlier. It's always good to do that because it's good to do that for the finals. Now, as we say now, really and truly what we'll be doing is trying to find probabilities. We use the normal distribution to find probabilities. In order to find the probabilities for the normal distribution for a variable x, first thing we have to do is normalize the variable. What do we mean by normalize? In order to use the normal distribution table, you have to normalize the variable. So the variable x, first thing you have to do is normalize it to the variable z, because we only are given the probabilities of z in the table. But the formula for z is, please remember, z is equal to x minus mu over sigma. In other words, z equals x minus the mean of the population divided by the standard deviation. That's the formula for z, or standardized normal variable. Okay? Don't worry, we'll use it in question. Nice. All right. Now, another thing that we must know is that the table, the normal table, gives us the probability of z when it's less than or equal to common letter z. All right. So the normal distribution, it gives us cumulative probabilities, in other words. It gives us cumulative probabilities. And the cumulative probabilities will typically represent it by phi of z. This weird looking symbol means phi of z. All right, not that it's important to know, but it's just good to know.
Okay.
So just to give you some diagrams here of how this is some normal table looking. So here it is, a normal table where the mean is 50 and the standard deviation is 10. Because remember, 100 would be 10 squared,
Okay.
right? The standard deviation from this one would be 10. All right. So in other words, if you were to use empirical rule, do you remember empirical rule?
Which one of the rule now?
Empirical rule. Empirical rule states that 68% of all data lie within one standard deviation of the mean. Never heard of empirical rule?
Yeah.
Okay, yeah. So we're saying that majority of the data set, look what I'm going to show you now. I'm just trying to connect empirical rule and normal distribution for you. So we're saying if the standard deviation is 10 and the mean is 50, 50 plus or minus 10. So we're saying that really and truly this part right here, in here, so makes up 68% of the data, which makes sense, don't it?
Yeah.
Yeah, if you look at it from 40 to 60, majority of the data lie there. The next thing empirical rule tells us is that 95% of all data lie within 2 standard deviations of the mean, which is bar x plus or minus 2 sigma. So in this case, 2 times 10 is 20. 20 plus the mean of 50 is 70. So come all the way up to here, and 50 minus 20 is 30. We're saying that this part now, if we continue to shade, would represent 95% of all the data. That makes sense?
Yeah.
Now, you know what we'll soon do? What we'll soon do is check it out. What we're going to do is check it out when we're doing questions like using the normal table. We're going to see that if we were to find the probability x is between 30 and 70, we're going to see if we get 0.95. Because empirical rules say approximately 95% of the data will be between 2 standard deviations of the mean. We shade it and it looked like 95%. So we have this 2.5% and this 2.5% remaining. So we use the normal table, we'll see if it is indeed true. So that's all we're saying. So I like us to always see the connection between the different topics together, just to see if they actually make sense, because there needs to be correlation. All right. So before we look at transforming, let's look at how we go ahead and do questions like these now. So sometimes a question might ask you to find the probability z is less than 1.5 or greater than 1.5. We're going to start with number 2 first. The reason why we're going to start with number 2 is because the normal table gives us probability for when it's less than. So what you're going to do, Charmaine, you're going to go to the normal table. This is for the probability of z less than 1.5. You're going to look for where you see 1.1. Remember, we need 1.15. So we know we need 1.1 in the z column. And then going across in the row, we need another 0.05. Because when you add those, that will give you the 1.15, right? So we'll go to 0.05 and 1.1. Because when we add those, that's what gives us 1.15. So now we need to see where that row and that column intersect. So the intersection, just going across the room, is right here.
87.49.
Yes.
87. Yeah.
As a percent, but because it's not a percent, giving them the decimal, we will say 0.8749. All right?
That is it. That's it.
Using the normal table. Easy, don't it?
Yep. The last 2 sessions, not so bad. Last week and this week.
All right. Now, here's where it gets a little weird now. When it's greater than, this is what you have to do. When it's greater than, the probability of z is greater than 1.15, it's going to be equal to 1 minus
Are you breaking up?
probability of z. I am breaking up.
Yeah.
All right, can you hear me good now?
Yes.
All right. So we're saying when you need to find the probability of Z being greater than 1.15, it's going to be equal to 1 minus the probability of when Z is less than 1.15. And the reason why we do that is I'll show you on the diagram. So let's go back to the normal distribution table. Look at the curve right here. If you're looking for 1.15, it's somewhere right here, right?
Yeah.
So if you go here and look at when Z is greater than 1.15, that would just be right here.
Yeah.
Don't it?
Mm-hmm.
But because the normal table would give us from all of the numbers coming up to 1.15, in order to find the probability it's going to be greater than, we have to subtract out what the normal table will give us. Make sense?
Okay.
All right, let's go back on it. Look at it, you know. So 1.15, the normal table give you the 0.8749. Almost 90% that. So we're saying that the normal table, see it here, give us this part that I don't shade. But we want the part in red, don't it?
Right.
It has to be 1 minus. 1 minus what they give you. So always remember, when it is greater than, it's going to be 1 minus. When it is less than, you just use the table. When it's greater than, it's 1 minus. Let's write that down. So the rule is the probability of Z greater than A, it's going to be equal to 1 minus the probability of Z less than A. Or if you're asked to find the probability Z less than A, you just use the table. You don't have to worry about anything. Cool?
Okay.
All right, so of course I have to give you one to try. So here it is. No, not the negatives yet. What if I had given you to find the probability Z is less than, let me say 0.75. What if I gave you that? What's the probability Z is less than 0.75? Here's a table.
I have a table.
Okay, great.
0.75. Would it be 7734?
Very good. 0.7734.
734.
Yes, 0.7734. What if a question had asked you for the probability that Z is greater than 0.78?
It'll be 1 minus Z is greater than 0.78.
Less than, not greater than, less
Sorry,
than.
less than
0.7. Yeah. So now you look what is probability Z less than 1.78. What is that?
1.78. It's not 1, it's 0.78.
Yeah, 0.78, 0.78.
0.7823. Are you minus
Very
1
good.
from it?
Yes.
Right.
So subtract 1 from it.
You just subtract it from 1.
Yeah, subtract it from 1 from it.
Okay. 1 minus 0.7823. 0.2177.
Good, 0.2177. Very good, that's correct. Now, Charmaine, you see in statistics, we really don't like negative numbers. So here where it gets a little bit funner. Now, it gets funner because look at this, we have a negative number now. Now, when you have a negative number, the probability Z is less than -1, it's going to be equal to 1 minus the probability Z is less than 1. We don't like to deal with negative. So that's how we remove the negative. Probability of Z less than -1 becomes 1 minus the probability Z is less than 1. So just to write down the rule, if the probability of Z is less than negative A, it's equal to 1 minus the probability Z is less than A. All right, that's the rule. So now we just go to our table and look at the probability Z is less than 1.
All right, hold on.
Okay.
Okay.
So go to our normal table and look at the probability of Z is less than 1. So 1 is right here, 0.8413. So we just go down, 0.8413. We subtract 1 minus that, and we get 0.1587.
Hold on. Oh, you said 1 is 8413, and you just subtract 1 from it.
Subtract 1 from it. Yeah. Now, here's the second rule now. When you're finding Z greater than negative 1, all right, you see, because it's greater than, you always start with the rule. What is the rule? The rule says once you see greater than, it becomes 1 minus the probability Z is less than negative 1. Well, here's the thing, Charmaine. Once we see Z is less than negative 1, this part wouldn't be finished yet. We'd have to simplify that further. So it would be 1 minus, in bracket, it becomes 1 minus the probability that Z is less than 1. But if you expand in the bracket, Charmaine, the 1 minus the 1 gonna cancel, and the minus become plus. So all of this works out to just be the probability Z is less than 1. Then we just use the normal table and conclude it's 0.8413. Now you don't want to be doing all of this work. So I'm going to summarize what the formula is. So the probability of Z greater than negative A works out to just be the probability Z is less than A. Isn't that beautiful?
Mm-hmm.
That's it. So it works out really nice. So you wouldn't have to do all of the showboating up here. You'd be fine with that. So I'm going to ask you two then. What if I ask you for the probability Z is less than negative 2.11?
Probability Z is less than negative 2.11.
Yes.
2.11. Is it 0.9862?
0.9862, that's your final
No, not 9826.
9826. So let's look at it.
So that would be 98.
Is this your final answer?
No, you're going to subtract 1.
Very good. You're going to subtract it from 1. Good. That will give you your final answer. 0.0174. That's it. Nice. What if I'd ask you for the probability Z is greater than negative 0.55?
Probability 0 is greater than 0.55.
Negative 0.55.
Point. Point 7088.
That's the answer?
It's,
are you sure?
8. Yeah.
Yeah, you're correct. I'm just testing your resolution. If you're confident, you're correct. That's right. All right, nice. All right, so that's how you would use to find these simple ones. But of course, in a test, that's not how it's going to come. What it's going to come is they're going to give you the variable x, and you're going to have to normalize it. That's always been the case. That will always be the case. You're going to have to normalize it, okay?
Okay.
So in that case now, we're going to have to normalize it. So you can do these ones for practice in your free time, 2.58. Tell me what's the formula for this one, just to run through them. Here are some that we can just run through. Probability Z
This is what the
than
probability of 1 minus the probability.
Very good, 1 minus. So you can work that out in your separate time. Good. What's the formula for the next one?
There is one for the negative one. Negative. You just look for that in the. You look for that in the table.
Look at this, and it have a negative there. How do we get rid of the negative? What should we do?
The probability of Z is less than
Less than?
Less than 0.87.
All right, so it's 1 minus the probability Z is less than 0.87. So you need to remember this rule. The probability Z is less than minus A. Please remember it here. That rule, right?
Okay.
So you have to remember that one. What about the third one? What's this going to be equal to?
One minus the probability Z is less than negative 2.88.
All right, now fix up that for me, because we don't like deal with the negative probability. So what's it going to be?
1 minus the probability Z is greater than 2.88.
All right, so remember, this is the final formula. Probability of Z just less than 2.88. So here's where we summarized it. Remember, when you want Z is greater than negative A, it just works out to be the probability Z is less than A. This one here. So you saw all of them easy, but then when you actually do them separate, you realize that it's just challenging to remember all the different formulas, right? That's the biggest challenge, just to remember all the formulas. So Charmaine, I want you to remember all of these four. Star here, star here, star here, star here. If you know these fours, normal distribution is the easiest topic. Like, supposed to done, if 10 normal distribution come on Wednesday, you should done the 10 of them in 10 minutes and have 50 minutes for the rest of the paper.
Okay.
Because you're just using the table, so it's really easy. But you have to remember the formulas. If you don't remember the formulas, then it becomes more challenging, right? All right, now, as I said, we're going to normalize, but sometimes a question can come like this too. Sometimes they can ask you some stuff like this. Them say if A and B are some numbers, and they tell you that it's the normal distribution, find A. So they might give you some question like this, saying like, whoa, yeah man, so they might ask a question like this. All right, find the value of B. So they have to try to make the thing hard, you know, they have to try to make the thing hard. So first thing we realize is that this is saying the probability Z is less than B is 0.9693. So what you do is go in the table and look for 0.9693. 9693. Here it is, 0.9693, right? That corresponds to 1.97.
Hold on. 0.9.
9693. That corresponds to what? 1.8 or 1.9? Is it 1.8?
Hold on.
Looks like 1.8. Yeah, 1.8. So it corresponds to 1.87,
Looking at
right?
the table, 0.9693.
Yeah.
What's the number you're looking for?
You're looking for 0.693.
No, man, the value of 4. What I told you to look for, what I was told to look for on the table.
No, you have to find out what B is. But since I tell you it's equal to 0.9693, you'd go and search where in the table give us 0.69.
Oh, so it is 1.8.
1.8 what? 1.8 what? $1.8?
Carry on. Yeah. Oh,
1.8 what?
I'm looking at it. 1.07.
1.87, not 0.07, 1.87. So in that case, you tell them B equal 1.87. All right. So that's how they like to ask questions sometimes, just to change it up, because everybody can look, everybody could find the probability Z less than 1.87 and get this. So now they ask it reverse way. See that? Reverse way. So we have to look out for question like that. So just to, for another follow up on part A, but if I'd ask you for the probability Z is less than 0.7324. What if the question that? Oh, sorry. What if the question that asks you the probability of Z less than J is equal to 0.7324? Then they ask you, what is J?
0.734, 0.7. Is it 0.763?
All right, let's go. Let's see, 0.7324. 0.7324. Here it is. So you said point how much? So that's 0.6. 0.63, not 0.73. 0.63, all right?
Hold on. Points. 724. 0.63. 62.
Yeah, 0.62. So J would be 0.62, 0.62. All right, now here's where it gets really dicey. It gets dicey because look at this one now. It says the probability Z is greater than A, and they give us 0.38. Now here's where it's off, because first thing we know is that, but wait, the probability tables start from 0.5.
Right.
So if you see 0.38, automatically you're going to use this formula. You're going to say greater than, then it becomes, remember the probability Z is greater than A becomes 1 minus the probability Z is less than A. And that's equal to 0.3802. Cool?
Cool.
Now this is where you then need to make, I just want some space for erasing this part. This is where you need to now transpose for what you want. So imagine if you saw this as 1 minus x equal y. This is the 1 minus all of this is your x equal y. And you need x to be by itself. So it's easy to say x equal 1 minus y, don't it?
Right.
It's easy to say that. So it's the same thing that we can then transpose it and say, so do some transposition to say now that the probability Z is less than A would work out to be 1 minus the 0.3802, don't it?
Okay.
So then after you do your subtraction, you're going to get 0.6198. That's the probability Z is less than A. So now you use the table, because now that you have it bigger than a half, now you can use the table.
So you couldn't just look at it and just minus 1 from it and then look in the table?
Can you repeat?
You couldn't just look at it and just minus the 1 and then look in the table with the value that you got?
Minus 1 from it, or
Right,
subtract it from 1. Subtract it from 1.
From 1, right.
Okay.
And then you just look in the table for it.
Okay, yes, you can do that. Yeah. All right, but I like to understand the reason why we subtract 1 from it though. I don't like to just tell us a SWOT way to remember it, because with a SWOT way you can run into problems. But with a way that you know what it means, remember from definition we said to find the probability Z is greater than A is what? Remember we said it from up here.
Minus the probability, yeah.
Exactly. So if we can just stick to the definition, then we would just get 1 minus the probability Z is less than A is this. But then remember, it's this part you want. So you have to transpose it to make it the subject, right?
Right.
So we just transpose and make what we want the subject, meaning we need it to be on one side by itself. So we'll bring over this over there and bring the 0.38 over here. So we transpose it to get what we want. All right?
Okay.
Now, once we transpose it and get what we want, now we want the probability Z is less than A. So we look in the table and see which one gives us 0.6198. Now, looking at it, there's no such figure. Always remember it's in order. Now, sometimes they do stuff like this, but notice that 0.3 have 0.6179 and 0.217. 0.698 is exactly in the middle. So that means it would be 0.305. That would be the number in the middle exactly.
Oh, because it's in the middle.
Yeah.
Right.
So it's 0.305.
Right.
So in a case like this, A equals 0.305.
Right.
Right? What about the third one? What are you going to do the third one for me? Part C says the probability Z is greater than A equal 0.7367. Talk me through it.
It's equal to probability minus the probability Z is equal to A minus, and then you transpose.
All right, so I want you to just tell me what A is. Work it out, tell me what's A.
Now go back to the table. Go back. 7, 3, 6, 7 equal 0.2633. We're looking for 0.2633.
Will you find 0.26?
No, it's not here.
So what you going to do?
No, but there's nothing close to it either.
So what you going to do there?
You're going to look for the value that is closest to it.
You still won't find anything close to 0.26.
Are we using the table?
So this is where you need to remember the definition again. So as I said, there's 4 definitions I said we need to remember. So remember another definition told us the probability of Z greater than negative A is the probability Z is less than A. So clearly, this question here must be some negative number. This question here must be some negative. If you bring it over and realize you're going to get less than a half, it must be some negative number. So clearly A is a negative number. But we remember that the probability Z is great. The probability Z is greater than some negative number. It's equal to the probability of Z is just less than A. So just gonna look in the table for which number is 0.73. So looking in the table, 0.7367. Here is 0.7357. So 67 would be in between the 3 and the 4 here. So that's 0.64. So now A is not 0.64 and A is negative 0.64. That would be our answer. All right.
Looking at it. Negative 0.64. So it's in between the 73.57 and the 73.87.
Well, really and truly could say 0.635, but I just work with 0.64. So if you said negative 0.635, that's really and truly the correct one, but I just said negative 0.64. That's fine. All right.
Okay.
So you have to remember that rule right there for part C. What about part D? Part D says the probability Z is less than B is equal to 0.0793.
Hold on. Is it 1.42?
1.42?
Yeah.
All right, so let's see. So first thing we realize is that they give us Z less than B, and we'll get a number less than a half. So that don't make no sense at all. So first of all, no, it must be a negative number. It must be a negative number because it can't less than a half unless it's a negative number. All right. So then we need to remember the rule that relates less than B with a negative number. That rule was right here. The probability Z is less than negative A is 1 minus the probability Z is less than A. So we can say, okay, what we need to do then is find this B is a negative number. We just need to find 1 minus this. So probability Z is less than, we don't know what that is, but we're going to find 1 minus of this number, 1 minus 0.793. So look in the table now. Let's subtract it first. This will be 0.9207. Or look for
right.
9207. That's here. That's 1.41. You were right, you know, with 1.41, but the thing is, it wouldn't be 1.41. It would be B equal negative
1.41, right.
All right. So you have to remember that, negative 1.41. And I'm telling you, in the multiple choice, it goes to the 1.41, negative 1.41, and two other answer that they're trying to set up persons for. All right, so that's how they like to set exams. They like to put two distractors and the correct answers. Then one answer that just don't make no sense.
Okay.
So that's that right here. All right, now, many times you're going to be finding answers that is between intervals like this. To find intervals like this now, what you just do is you work out, all you're going to do is work out phi of the bigger number 2 minus phi of the lesser number, the negative 1.87. That's all you do. What do I mean by phi? Just look in the table. Now, we run into some issues when we do the second part though. We run into some issues because there's nothing in the table for when it is negative. So when it is negative, you're gonna have to do what? Subtract. So then it's gonna become phi of 2 minus, in this bracket becomes 1 minus phi of 1.87. All right, we have to subtract it from 1. Now we're good to go. So now you just use the table and look for the probability when it's 2. That's what we mean by phi of 2.
Hold on. No, go back.
Go back. Oh,
Yeah, right here.
okay.
So all right, after you work out the equation, what you said next? You say you look for what?
So we're going to look for the probability when the z-value is 2. That's what phi of 2 mean. Use a table for 2.
Okay.
So using the table for 2, we just go down to 2.0 now. Here's 2.0, 0.9772, right?
2.0, 0.977, yeah.
So look at that. So that becomes 0.9772. Subtract in the bracket 1 minus, you look for 1.87. So go back and we'll look for 1.87. This is 1.87, already have it. 0.9693, don't it?
1.87.
Yeah, 0.9693.
Right.
So now we can subtract them. So you take out your calculator and you put that in. Now make sure you just bracket it entirely like that.
Is it minus 0. No, not 0.
9772 minus open bracket
93. So it's 9.772 minus open bracket 1 minus 0.9693. 9772.
That's it. That's your final answer.
What you got? I didn't get that.
0.9465.
It's not supposed to be 0.9693. You have 0.
Yeah, it's 0.9693, then I close the bracket.
Yeah, that's what I did, but I'm not sure. Let me go again. 0.9772 minus open bracket 1 minus 0.9693 close the bracket equal. Okay, yes.
All right, so make sure you type it in the calculator correct from the get-go. You don't want to be having any calculator mistakes, all right?
Okay.
Yeah, so just type it as slow as possible in the calculator one time. So we really don't want to make no calculator mistake, because I'm telling you, they're going to leave the answer for those who make the calculator mistake, right? That's just how we have to set the exam. So you want to make sure that you don't make any calculation mistake. Cool.
Okay.
Now, when you're going to work out this now, as I said, so let me write down the rule. Just to write down the rule. So the probability you're finding when Z is between A and B, it's going to be equal to phi of the bigger value B minus phi of the smaller value A. That's it.
Which of the rule is this? One that you just did?
Yeah, for the question we just did for A.
The probability of A is greater than Z.
Less than Z, A is less than Z.
Yeah, A is less than Z.
And Z is less than B.
And Z is less than, is that B?
Yeah, B. B. It's equal to phi of B minus phi of A.
It's equal to phi of B minus phi of A, which is the bigger number, right?
Yeah, that is it. All right, let me copy this question, take it to the blank doc here. So we're gonna do this second one now. So this second one says find the probability Z is between negative 1.2 and negative 0.5. Now here's the trick. Well, no trick. First thing, it's going to be phi of negative 0.5 minus phi of negative 1.2, right?
Right.
But because it's negative, we remember that phi of negative A is 1 minus phi of A, right? So in that case now, this is going to become 1 minus phi of 0.5 minus 1 minus phi of 1.2.
What you do? Whatever you do to the right, you do to the left.
No, we only do that to the left because both of them negative. So
Oh, okay, yes.
Because both of them were negative. So that's the only reason why we did that. So now we can look in our table for what's phi of 0.5. So look for 0.5. 0.5 is here, 0.6915. So it is 1 minus 0.6915 minus, in bracket, 1 minus phi of 1.2. So look for 1.2. 1.2 is here, 0.8849. That's 0.8849. We do our subtraction, 1 minus 1. Well, do your subtraction, you put in a calculator. I usually like to do it without calculator, but for safety, just do it in a calculator. And make sure you put your bracket. If you don't put a bracket, you're going to get a mistake. I'm telling you, you have to use a bracket.
0.1934.
Exactly, 0.1934. Very, very good. All right, now, what if Let me give you the next one now. You're going to walk me through this one. Probability Z is between 1.15 and 1.88.
Where it is? I'm working it. I'm not put it.
All right, let me put it on the screen.
Probability Z is 1.15. So that is going to be so we're going to have, what do you call it?
Phi of what?
Phi of 1.88
Yeah.
minus phi of 1.15.
Mm-hmm.
Then you're going to look in the table for phi of 1.88.
Good. Look in the table and tell me what you get.
1.88 is 9699. 9699.
The 0.9699 minus
0. Phi of 1.5, 1.5.
1.5.
1.15.
Okay.
1.15. 0.8749.
Very good. 0.8749. You're absolutely correct.
Let's subtract now. 0.999 minus 0.8749. 0.095.
0.095. Yes, that's correct. That wasn't too bad. That wasn't too bad. Good, good, good. All right. So what about this one now? Let me go for it. Put back in a negative in it.
So that one is probability that negative.
This one, you see this one, it also has a very special property to it, which we'll do in a topic known as hypothesis testing.
Is this 1.96. So you're going to have phi of what is it? 0.
Or you get 0.
0. Oh, don't worry.
This is phi
So
of
phi
what?
of 0, negative 1.96.
You start with the B value first. B is this one.
Right.
So it's 1.96.
1.96, right.
Minus
1.96 minus negative 1.5 of negative 1.96.
very good. But what do we do with the negative?
We're going to subtract it from 1.
Very good.
Right. So you're going to
minus what we're going to know?
Hold on. 1 minus 1 minus 1.96.
phi of 1.96. Now remember to put your bracket. If you don't put your bracket, you're gonna get mistake, all right? So please put your bracket.
Right, I'm doing the same thing.
Please remember to put your bracket around it.
Bracket 1 minus phi of 1.96, close the bracket.
Good at that?
Yeah.
All right, so now we can just expand in the minus. Well, when I mean expand in the minus, I mean put it in your calculator. So you put in the calculator now. Well, actually, you'd have to tell me what.
I have to take the value first. What is the value
Yeah.
of 1.96?
Yeah, because I know it, but I'm waiting for you to tell me.
The value of 1.96. 0.9750. 0.9750 minus 1. 1.96. 1.96.
You just told me it's the same thing.
It's the same thing.
0.975. Yeah.
Right. One minus. So working on 0.9750 minus, open the bracket, 1 minus 0.9750. You get 0.95?
Very good, 0.95. Now, without doing the question, you're going to know that this is 0.95 after we do a topic known as confidence interval. You ever heard about it?
No.
So confidence interval, that's the last thing that is on the, I don't know if you look through the syllabus, but that's the last. After sampling distribution, then you have confidence interval and hypothesis testing. Those are the next 3 topics that will be tested on the final exam. So you have what we call 95% confidence interval. 0.95 is 95%. So there are some values that should always stick to you. 1.96, 1.28, 1.28. There is 2.64. Those values soon come in key. We're doing confidence interval, all right?
Okay.
But don't worry about it for now. I'm just telling you a heads up of how we're going to use normal distribution. Normal distribution later on. So you see how statistics, everything linked down.
Yeah.
Make it nice. It's nice when they're all connected. So now, of course, these are the way it's going to come in exam now. So after this is pure exam style question. You're going to wonder, what is that? This is how they're going to give it in exam now. In exam, you're going to have to standardize it. So let's standardize part A together. So part A, it tells us that X follows a normal distribution with mean 100 and variance 25. Always remember right here is variance given. So you can put it in a form that's more suited to you then. You can say X follow a normal distribution with mean 100 and put it as 5 squared. Why I put it as 5 squared? So I can say my standard deviation is 5, right?
Right.
So now the first part, part A, it tell you say you need to find the probability X is less than or equal to 100. The first thing you need to do is standardize it. The standardized formula for Z is equal to X minus mu over sigma. Didn't we say that? Right?
Yeah, X minus mu over sigma, yeah.
In other words, our X now is what's right here, the 100. minus our mu is what was up here over our standard deviation, which we said is 5. So in that case, Z works out to be, for part A, 100 minus 100 over 5. So now we can show the working. We'll convert it and say the probability Z is less than or equal to 100 minus 100 over 5. 100 minus 100 is 0. So we find the probability Z is less than or equal to 0. But the probability Z is less than or equal to 0, we know that's just a half. Without doing anything, we should know that's a half. Without even looking at the table. That one should be stored in our memory permanently, right?
Go back. Let me see something. Go back to the working out. Z is equal to 100 minus 100 over 5. Yeah, because I 0, because I got 0, I never know. And I wonder, oh yeah, I get 0.5 because I got 0 before. When I do the calculation, it's 0.
Yeah, so now you go to the table and look for 0. Remember, it always come back to the table.
On the table, yeah. But no wonder how you get that.
All right, so always remember we're coming back to the table. Cool? Pull it out.
Yeah.
Let's do part B now. Part B, we need to find the probability X is between 92 and 95. So of course, first we need to standardize it to Z. So this can become the probability Z is between, standardize the left part. Your X is 92, so it's 92 minus the mean of 100 over the standard deviation of 5. Standardize the right side, 95 minus 100 over the standard deviation of 5.
Why is it over 5 and not 25? Isn't that the variance?
The variance is 5, but you divide by the standard deviation. The variance is 25, but the standard deviation is 5.
Okay.
So you divide by the standard deviation, all right?
Okay.
So now we just work it out. 92 minus 100 is negative 8. Negative 8 over 5 is negative 1.6. And then 95 minus 100 is negative 5. Negative 5 over 5 is negative 1. So now this is what we want. The probability Z is between negative 1.6 and negative 1. That's what we want. When you get to this stage, it will easy now, because now we just say it's phi of negative 1 minus phi of negative 1.6. Now we know how to do that already. We know, so because it's negative, it's gonna end up become, I need some more space. It's gonna end up become 1 minus phi of 1 minus 1 minus phi of 1.6. In order to get rid of the negative, right? Pull it that?
No, looking at it. Okay.
All right.
So now you're going to the table.
Yeah, so now we're going to the table. All right, I think, all right, so the PDF reader just freeze. All right, so I'm gonna have to and I'm gonna lose all the annotations. Oh gosh. All right, write down that last statement for me because the program
-1 and negative
minus. Yeah, just write that down. I'm gonna have to read.
Oh,
Gonna have to
minus.
close and reopen. All right, sorry about that. So I'm just opening up back up the document. That's a program free, so that's what usually happens. I'm just locating where I saved the document.
Okay.
Yeah, so we're gonna have to relocate to Microsoft Edge. And this usually happens because my subscription expired for Zodo and I need to update it, but not gonna update it right now. So just give me a second as I reopen the documents.
You work on Saturday at JC?
Yeah, I teach extra classes at school.
You work every day?
Every single day.
So you don't rest?
Don't need it.
You
Right.
mean by you don't need to rest? Your brain needs to rest?
No, my brain, it's pretty good. It's pretty good.
Appear months in your brain. Anything to do statistics for the brain.
Yeah, the same way we exercise on a daily basis, it's the same way our brain needs to be exercised daily. So pretty good. All right, let me relocate now to Microsoft Edge. So we're gonna have to be in Edge today, as I said, because.
Are you an athlete at one point?
Repeat?
Were you an athlete at one point?
Yes, I used to do some running. When I was in university, I did. All right. Go down here. That's a blank document. Normal distribution document, no. Because I saved the files and it's in different folders. That's why it takes a while to relocate them. Right, should be here. It's a normal distribution. And I need a normal table. All right, I need a normal table. Where did I put the table? Table. Okay, here it is. All right, so I got everything in Edge. Can you see the Edge now? We're in Microsoft Edge. Can you see?
I'm only seeing the table now.
Oh, the table. Good. That means you're seeing Edge. So I opened it in Edge. So going back to the question we were at, You were right here in part B. And in part B, I really don't like edge features, but we're gonna have to work with it. Prefer use the feature I was subscribed to, but for part B, we were here and we had got this part where it reached phi of -1 minus phi of -1.6, right? That's as far we have gotten to for this question, right? So now this becomes 1 minus phi of 1 minus, this part become 1 minus phi of 1.6. Cool with this? Are you hearing me, Charmaine? I'm not hearing you.
Yes, I'm hearing you.
Okay, okay, great. So now this is where we just go back to our table again. So go back to the table, we look for phi of 1. Phi of 1 is 0.8413.
Phi of 1, hold on. 0.8413, right?
Subtract 1 minus, we look for 1.6. 1.6 is
94.52.
very good, 94.52.
And then you do the subtraction.
Yeah. -0.9.
Yeah, cut this. Okay. You're going to get a negative figure.
No, you won't get a negative.
0.945.
0.1039.
Minus.
Just to bring up the calculator, I actually did it with my calculator in my hand. This one, but
yes, that's correct.
Yeah. So you're good. All right. So no bother to bring up the screen. That's good. All right. So part 3. Walk me through part 3 now to normalize it. I'm going to write it on the blank document for more space. X follows a normal distribution. All right, let me take off the O. X follows a normal distribution of mean 100 and variance of 25. Part C now wanted us to find the probability. X is between 105 and 115. How are we going to do that?
The probability of move your color thing. Let's see what is here. Your ink. 115 minus 100.
All right, good. So it's a probability of 105 minus 100
over 5 divided by 5.
Good.
Greater than.
Less than.
Sorry, less than X.
Not X now, Z. When you standardize, it becomes Z.
Less than Z. Less than 115 minus 100 divided by 5.
Good.
We do the calculation.
Good.
That is 1.
1.
Right. Z. Is it less than or equal to?
Yeah.
Three.
Good.
is less than or equal to 3, you only have.
Well, it doesn't matter if you put less than or equal to, because we're going to use the table. So it don't matter, right?
Okay.
Just looking at 3 anyway. So what's going to be the next line?
And you're going to find the value of 1.
1?
No. What is something the name again?
Phi.
The phi. Phi 1.
Phi of 3 first.
Oh, phi of 3 minus phi of 1.
Good. What's phi of 3?
Phi of 3 is 0.9987.
0.9987 minus
Phi of 1 is 0.8413.
0.8413. Good. All right, so subtract them and tell me what you get.
0.9987 minus 0.8413. 0.1574.
0.1574. Very good. That's it. Easy, don't it?
Yeah, I just need to remember the formula and go over it. Because I actually get that the last 2 sessions that you did. I just need to go over independent and
Oh, probabilities. And I send you the solution so you can do every question and go back through them, right?
but the last set that we did last week, I understand that better. I know to calculate those really good.
Okay,
So
good.
just this.
Okay. Oh, probability distributions. Good. Good. Nice. All right. So now the last one, let me see. The last one. Oh, the last one was saying the probability Z, probability X is greater than 110. How do we do that part now?
Probability Z.
X is greater than 110, not Z.
So you're going to the probability X. Is 110.
So Z, not X. When you're going to do the standardizing, it becomes Z. So 110.
Z, right? 110 minus 110.
Minus 100. Remember, the mean was 100.
100, right? Divided by 5.
Good. And the reason why I'm stressing writing the correct thing is because I think for your finals, you'll get a mixture of structured and multiple choice, right?
I'm not sure this is multiple choice because it's online.
Oh, so it's straight multiple choice?
Yeah.
Oh, I thought.
Yeah, I think they said online.
Okay, I heard it was going to be a
But I don't know. They didn't. I don't know. I'm not sure.
Okay, all right. So 110 minus 100 over 5, what's that?
2.
2, that's 2. So the probability Z is greater than 2. How do we work out the probability Z is greater than 2?
You look in the table? No, 1 minus.
Very good. 1 minus the probability Z is?
Less than 2.
Less than 2. Now you're going to the table.
Right.
So all of these stuff must remember.
So 2 is 0.9772.
972. 972?
No, man.
9772. Okay, so
0.9772.
Good. So you get 0.0228.
Right.
Good. That's your answer. That's correct. All right. Now let's look at an exam style question now. What I mean by exam style meaning it's going to be worded. They're not going to give it so smooth where it's easy for you to just put in and look on the table. I'm going to put a bag of chat in. So if you just look on the midterm packet, just quickly, I'm just scooting through. I'm going to give you a bag of chatting, right? They're going to give you a bag of chatting. That's just how it is. Whole heap of bag of chatting. So let's look at when them give you a question with a bag of chatting. Here's a question here with a bag of chatting. It's a the lengths of a metal strips produced by a machine are normally distributed with mean length 150.
This is the exam packet. It's not the exam packet.
No, not yet. We'll soon go to the exam packet.
Okay.
We're doing two.
Okay.
We're doing two of my questions first, and then you go to the exam packet.
Okay.
Right? Yeah, just doing two worded problems, then exam packet. Cool?
Okay.
All right. So it says, the lengths of metal strips produced by a machine are normally distributed with mean 150 and a standard deviation of 10. Find the probability that the length of a randomly selected strip is shorter than 165 centimeters and within 5 centimeters of the mean. What are we going to do part A? Before we do part A, what is all of this telling us?
No way that's a mistake. So the strip is shorter than 165 centimeters.
All right. So what is all of this?
5 centimeters of the mean.
What is this telling you though? When they say normally distributed with mean, the first thing I want you to do is set up what they gave you. They're literally telling you, let X be the length of the metal strips. They're telling you X follows a normal distribution with mean 150, comma, standard deviation is 10, so the variance is 10 squared. Isn't that so?
Yeah.
Now we can go ahead and start the question. Now we can say, oh, now they want for part A, the probability shorter mean what? Less than or greater than?
Less than.
Less than. So now they want the probability X is less than 165. Literally, that's all they're asking us. So we need to do what? We need to standardize it, right?
Right.
So standardize it, it becomes Z is less than
165 minus 150 divided by 10.
Exactly, that's it. Good. So do that now. 165 minus 150, that's 15. 15 over 10 is 1.5. Just in the interest of time, we speed that. So that's the probability Z is less than 1.5.
Right.
What do we do next now?
Minus 1 minus the probability. No,
it's in a form that we like. So let's go straight to the table. No need to subtract anything.
1.5 is 0.9332.
0.9322.
No, 0.9332.
9332. Okay, 9332. Good. Now part B. Part B says within 5 centimeters of the mean. What does that mean?
Is it going to be greater, less than or equal to?
Less than or equal to? What do you mean? Because that could be right, but that could also be wrong. You have to expound a little bit.
Within 5 centimeters of the mean.
What's the mean?
Means 150.
Exactly. So within 5 mean you can either less than 150 by 5 or you're greater than 150 by 5.
Right.
That is within 5 centimeters of the mean, all right? Call it that? So you see what they like to say the words.
So why, if it is less than 150,
it's still within. You can either be within by being 5 centimeters less or 5 centimeters.
No, but why you
greater.
choose 145?
Because
okay, all right.
Yeah.
Yeah, I understand.
Yeah, that would also be within 5 centimeters.
Right.
So now we just need to work this out. So we'll standardize it. 145 minus 150 over 10 less than Z less than 155 minus 150 over 10. The interest of time, skip out the calculator. We know that would be -1/2 less than Z less than 5 over 10 is 1/2. Now we're just gonna get phi of 1/2 minus phi of -1/2. But we know we can't do phi of -1/2. So this part really working out to be phi of 1/2 minus, in bracket, 1 minus phi of 1/2. So look what phi of 1/2 is.
Which is 0.5.
0.5 1/2 is how much?
0.6915.
0.6915. So it's 0.6915 minus, in bracket, 1 minus 0.6915. Which is that? Put in the calculator. 0.6915 minus 1 minus 0.6915. 0.383. Pull it that?
Yeah.
Cool. Let's look at one more of my worded problems that will get to the midterm packet. So as I said, typically they love to put it in words like this because they know that if they make it too straightforward, it becomes easy, but they like to see if we're able to translate it in real life. So notice it's real life when you put it in words. For example, it says the time taken by a student to attend class is normally distributed with mean 12 minutes and a standard deviation of 2 minutes. The student walks every day. Estimate the number of days during the year when he takes longer than 17 minutes, less than 10 minutes, between 9 and 13 minutes. So I guess this person lives, these students live very close to school because 12 minutes is very close.
Okay.
Yeah, when I read questions, I just like to do the analytics behind it. You know, just picture what's happening, start to see it. 12 minutes, that's within maybe a 1 mile from school, less than a mile, close by. We're gonna do part A.
You're going to find.
So first thing I said, always set up the distribution. So X follows a normal distribution with, what's the mean?
12 minutes, so 120 minutes.
So 12, 120.
No, you know.
12 minutes. The mean is just 12 minutes, so 12.
Angle. Okay. Oh, I was thinking about it. Yes, right.
Comma, and the variance is 4. Can I just put 4 there?
Hold on. The variance is 2 minutes. Where you get 4?
No, the standard deviation is 2. Remember, variance is a standard deviation square. So you're used to seeing me put it as 2 squared.
Right.
Reason why I put it as 4 is because I want you to get used to seeing when they'll do it like that on test 2. All right? So I put it as 4 just for you to get used to seeing. Sometimes it might come this way and you would have to deduce that, oh, the standard deviation is 2.
Right.
So now for part A, it says no longer than 17 minutes. No longer mean what?
Can't be more than 17 minutes.
Can't be more. So X is less than or equal to 17. How we gonna work that out now? So standardize it.
So it's going to be 17 minus 12.
Good.
Divided by 4.
Very good. So you work that out for me now. 17 minus 12 over 4. That is 5 over 4, negative 1.25.
At 1.25. Look for that in the table now.
Look for this in the table, negative number.
No, minus. Minus 1 from it.
So this becomes, once it's a negative number, it becomes 1 minus. 1 minus phi of 1.25.
Right.
So 1 minus, what's 1.5 of 1.25?
What do you say? We're getting a negative 0.25.
With 1.25, look at the table, 1.25. We go back.
1.25, 1.25, 0.8944.
Good, so put it there. 0.8944. Then you subtract it, you get 0.1056, don't it?
Yeah.
Nice. Now part B, you want the probability it's less than 10 minutes. Hold on to part B. All right, I need some more space. So
less than 10 minutes.
Let's go to the blank page and finish it.
So it could be 8 minutes, it could be 9 minutes.
Distribution of 12 for, we're working out the probability. X is, how much it said? Less than
10 minutes.
Less than 10 minutes, yeah. So it could be, as I said, 8 minutes, 9 minutes, don't care. As long as it's less than 10 minutes. We'll find that probability.
We're going to file.
So we normalize it first.
Yes. We're going 17 minus 10.
So 10 minus
9.
10 minus 10 minus the mean.
12, right. 10 minus 12 divided by 4.
Over 2. Remember, you know I made an error in the first one. Oh gosh.
It's supposed to be 2 and not 4.
Yeah, I think we divided by 4 in one of them.
The first one.
Yeah, it should have been 2 because remember the variance is 4, so the standard deviation is 2. It's a good thing we catch on though. You can fix that. So that's the probability C is less than. And I'm telling you, they're going to put the answer forward 4 enough because they know that's the trick. So 10 minus 12 is -2 over 2, that's -1. How do we find the probability C is less than -1?
Phi of.
Negative here, and you go to phi already?
Probably 1 minus.
One minus what?
Probability.
1 minus phi of 1. So now you look at what 1 is in the table. What's 1 in the table?
0.8413.
Very good. So subtract and we get 0.1587. That's it. Cool. All right. Now we're going to jump to the midterm pocket now. Let's see how they're going to be giving us these questions on exams. All right.
Okay.
So now let's look at how they're going to put it on exams. So as you can see, look at this here. It says, a researcher interested in age at which women are having their first child surveyed 250 women having at least one child and found that the normal distribution with mean age of 27.3 and a standard deviation of 5.4. Approximately 95% of women have their first child between the ages of. Now you see how they make the question seem like it's hard, don't it? Now, all they're asking you for, this is all they're asking you for. Approximately 95% of women have their child between what age? All they're asking you for is to work out this. The probability that it's going to be between A and B, and that must equal 95%. 0.95. And we just need to find what A and B is. That's well easy now, don't it? Does it give you the percentage? Remember, that is why we were doing the activity when I show you when they ask you like Z is less than A equal to 0.964. Remember we were doing that activity? This is where it's going to come in handy because they're going to ask you a question where you have to equate it to the probability and find out what's the value for A and B. Cool? But they tell us that it is normally distributed. X is normally distributed with mean. They said the mean age when women have their first child is 27.3. I think that's very accurate. So that looks like they actually carried out the research. This seems very accurate. And a standard deviation of 5.4. That also seems very accurate. So some good stuff in this example. So they're giving you a practical usage here. You said very practical, don't it? So now let's go ahead and standardize our variable. So standardizing it, we need to find the probability that Z is between, this would become A minus the mean 27.3 over A minus 27.3 over the standard deviation 5.4. That's less than B minus 27.3 over 5.4, and that's equal to 0.95. In other words, what we're saying, I need some more space. Let's go to the blank doc and finish it. In other words, we're saying that, that's why I don't like edging out, it takes so much space. So this is now phi of, there's the midterm, here it is, b minus 27.3 over 5.4. So b minus 27.3 over 5.4 minus phi of a minus 27.3 over 5.4. This works out to be equal to 0.95. That's what we're doing. Now we can look in the table and determine b, and this is where I tell you that there are just some values we must memorize. We must memorize them. I know straight away this is 1.9. This value in here so need to be, it have to be 1.96. This value in here so have to be 1.96. This have to be negative 1.96. Them expecting you to remember that. You wonder where I get that from. You probably say, slow down, slow down, slow down. Let me slow down. Remember when I asked you this question? Question 3D.
Okay.
You remember this?
Yeah.
And I said we'd have gotten 0.95. Before the question even pop up, we should have known that it would have been 95% a confidence interval, don't it? And I was saying that's a topic we're going to touch up later on. So this is how I can really say that this is cruelty. Because really and truly, most persons won't memorize this. That's just the truth. So that is, I put it in the wrong place, sorry. Phi of 1.96 minus phi of negative 1.96. I'm just telling the truth. Most persons won't memorize that this is that right there. You get what I'm saying?
Yeah.
So if in this bracket is 1.96, so we're saying b minus 27.3 over 5.4 equal 1.96. So we need to make b the subject. So we cross multiply. So b minus 27.3 equal 5.4 times 1.96, right? Cool with this part?
Yeah, go ahead.
So we'll multiply 5.4 times 1.96, and we'll get 10.584. And that's b minus 27.3. So b gonna be equal to 27.3 plus 10.584. So plus that to 27.3, you get 37.884. That's b, 37.884. So let me just look at which one with that. All right, 38.1. 38.1. They did some rounding off. We need to do some rounding. Yeah, 38.1 it is, because they did some rounding off. So right here, let's find our a, and we'll get it quickly. So to find a now, we're going to set this part up there to be equal to negative 1.96. So a minus 27.3 over 5.4 equal negative 1.96. Cross multiply 5.4 times negative 1.96 is negative 10.584. And so a would be add 27.3 to that. So a would be 27.3 minus 10.584. I'll get 16.716. Now we didn't round off, bear that in mind. They would have done some rounding off, so we'll look which one that is. So we're looking for 16.7 to 37.9. So looking for that. 16.7 to 37. See here, it's really 16.5. The calculations vary because they probably would have rounded off a couple times, but that it is 16.5 to 38.1. Cool with that?
Yes. So
Right,
this mid-semester
repeat.
package is 1 hour. You see how long this question is? I said the mid-semester package is 1 hour. Look how long this question is.
Yeah. So I'm telling you that you have to be spot on with your calculations, moving quickly, all of that good stuff. Have to be. All right. But don't worry, you'll be fine. Once you practice over everything and do them papers, I'm also going to send you my normal distribution in the morning, the multiple choice for you to practice. Once you practice and you want to be working. Also, what I'll tell you to do is when you're practicing, have a time limit to replicate the exam, okay?
Okay.
Have a time constraint so you're conscious of the time. So question 28 says, a bag contains 7 marbles, 5 white. The 3 marbles are drawn without replacement, one after the other. Let X be the marbles in the sample. Which of the following is not true? It says, which is not true? It says X is discrete. Well, X is discrete, so that's out of it. Discrete just mean it finite, right?
Right, countable numbers.
Countable, so that's okay. It says the possible values of X are 0, 1, 2, and 3. It says, let X be the number of red marbles in the sample. How many red marbles are in the sample?
7.
7, so this doesn't make no sense, right?
7.
It should be 0, 1, 2, 3, 4, 5, 6, up to 7, don't it?
Right. You just stop at 3, so that is out.
No, wait, let's read back what they say. 3 marbles are drawn. Oh, if 3 marbles are drawn, the maximum red we can draw then is 3.
Right.
So it's okay as well. So we'll come back down and we'll say, okay, that's good. Now it says X is a binomial variable. Well, the only way to determine if X is a binomial variable, if X is a binomial variable, it must obey these properties. Binomial variable, where it must follow a mean NP.
Right, it's true. There must have a failure and a success.
Yes, so N would be, if we're looking at this here, I want to determine if it's this now. We need to realize that whatever we get for the probability of getting 3 successive reds should be P. But from this, P should be equal to, let me see, the probability of getting P. What should be the probability of getting P? P is, what is P again? Probability of success. All right, wait, give me a second. I have a call to take here.
Okay.
All right, I am so sorry about that. So sorry. Are you here, Charmaine?
Yeah, so the answer is C, because the other two statements are true.
Okay, the others are true.
Yes, the probability of getting a red marble on the first
Would be
draw is
7
out of 12, and red is 7, there are 12 marbles, 7 and 5 is 12.
Yeah, that is
And the
true.
probability of getting a red marble on the second or third draw is depending on what was
Very
drawn.
good, yes.
Right? It's true.
So let's just show them though. Let's say it was a paper two. The probability of getting successful now, it says X is a number of red, right? So the probability of getting red, as you just said rightfully, is 7 out of 12, right?
Right.
Cool. So let's determine if it's really, this is success. Tell me that as a decimal.
7 over 5, 7 over 12.
What is this?
0.583.
0.58. So let's determine if it's really a binomial distribution. So n in this case would be 12, right?
Right.
N in this case is 12. So we need to decipher if when we find out what our P is, it should be 0.58 using binomial distribution. All right, so what we're going to do is set X equal 1 and solve back for P. Actually, that's going to be a lot of work, but clearly it's not going to be 0.58. So that's the only one which is not true. It's not a binomial distribution, but it's a lot of work to show it from here. What I'm saying is if we were to get one red straight away, we're setting it equal to, remember the formula is N choose X, in this case it would be 1. So 12 choose 1. P to the X, P to the 1, Q to the N minus X. 11 minus 1 is 12. I mean,
1 minus 12 is 11.
Yeah, 12 minus 1 is 11. Yeah, sorry. So I'm saying now that when you solve for P, it clearly won't be 0.58. But to solve this equation, I'm going to take some time. So I know about to do that. So we knew that C would be the one that's out. So very good. Now, question 29, it says, I love when they give us like this, you know. We don't even need to bother read the question, though. Then puts it in the form for us that we need, right? They give us the mean is 20 and the standard deviation is square root 5. Please bear that in mind. The standard deviation would be square root 5. If the variance is 5, the standard deviation is square root 5, all right?
Right.
So now it says, what is the probability it will require more than 25 minutes? So the probability X is greater than or equal to 25. In that case, it's just going to be the probability Z is greater than or equal to 25 minus 20 over the square root of 5.
Right.
I'll punch that into our calculator. 25 minus 20 over the square root of 5. Usually I'd know this straight away, but that's fine. We get square root 5. Square root 5 is 2.23. The probability Z is greater than 2.23.
Right.
Now we can't use the table yet. We have to work out 1 minus the probability Z is less than 2.23. So now we can look in the table for 2.23 and subtract it from 1.
2.23 is 0.9893.
9893?
Yeah.
Am I looking?
0.23, you said, right?
Yeah. I have 9871.
0.23. Which one is it? Oh, 2.3, that may look on. 0.8, what is it, 0.823?
98, yeah, 0.23, 2.23.
2.23?
Yeah. I'm seeing 0.9871.
Yeah, I was looking at it wrong. Yeah.
Okay, no problem. So that's 0.9871. So 1 minus 0.9871. All right. Ooh, that's not gonna be there. Why is that off? Let me check back the calculation. 25. What is the probability? What's the probability to require more than 25 minutes? All of these are off. I'm telling you for a fact, none of these are true. So I don't know what's this. None of these are true. 1 minus 0.9871. None of those are true. 25 minus 20. I see what the error is, you know, I see what the error is. So what would have been the error is they would have set the answer for this being when you divide by a regular 5, but the standard deviation is not 5. So this is madness. So you should point this out to your lecturer. Point it out, trust me. So this, you can't be setting errors in the question knowing that students are going to practice from these papers. All right? So they can't be doing that. Because then somebody's going to say, oh,
they don't work out the midterm packets,
they don't?
you know. No, they don't.
They just set questions.
Yeah, they don't work on the midterm packet. They don't.
They don't. They probably don't even check over the answer. They just say, oh. So this has an error in it because the standard deviation is square root 5, but they would have worked it out with regular 5. And if you work it out with regular 5, 25 minus 20 over 5, that will be 1. And the probability, 1 minus the probability z is less than 1. That would be 1 minus 0.8413. So you're gonna see A as the answer, but that makes no sense because the standard deviation is not 5. So that has an error in it. So they need to fix that. They absolutely need to. They need to. Can't believe it. Big practice paper and they do that. That's very disappointing. All right, so the next one there now, it says Tina's score on her midterm was at the 50th percentile. Let me see if you know what's up. 50th percentile mean Tina's score was what? What's another word for the 50th percentile?
The mean.
The mean?
No, Q2.
Q2, the median.
Q, right.
So her Tina's score is the median.
Right.
So if you were to arrange them in order, be in the 50th percentile, Tina in the dead stamp middle.
Right.
So Tina in the middle. So Tina's score is the median. Now it says the grades are normally distributed. Now when it's normally distributed, it means the data set is symmetric.
Like,
so
right.
the median equal to the mean. So it's also giving us our mean. It says the exam average was 78 and the standard deviation was 6. What was Tina's score? What's Tina's score? It's normally distributed. We just said it.
50%.
What was Tina's score on the exam?
50%.
Tina wouldn't score 58%. What was the average grade?
78.
If that's the average grade, what was Tina's score?
78.
78, because the
78.
median equal the mean, because it's normally distributed. When
Right.
it's normally distributed, the median equal the mean. So that's Tina. Tina get the class average. So 50% of students beat our score, 50% of students get less than our score.
Right, yes.
Right, so Tina was just about the average of 78. That's actually very high. That means that test was either very easy or Everybody is doing really well, right? Let's go with the latter. Everybody is doing really well. Now, question 31, it says, Marsha recently had a baby, right? They seem like they love to talk about babies in their practice test, man. Look for a baby. So Marsha recently had a baby. She named him Mark. Marsha was told that the weights of the babies born in the hospital are normally distributed with mean 7.5 pounds and a standard deviation of a quarter. Mark's weight at the birth was in the 15th percentile. How much did Mark weigh when he was born? Oh my gosh, 15th percentile? That's really bad for Mark. That's less than Q1.
Yeah, I was just going to say Q1, you know.
Yeah, so Mark is a little bit off in terms of his weight.
7.420.
So first thing they tell us that it follows a normal distribution with mean 7.5 and a standard deviation of 0.25. So the variance will be 0.25 square. So in that case now, we can say, okay, now it told us that he was in the 15th percentile. So the probability, we need to find what his weight is. So the probability X, we don't know what his weight is. So we want to find the probability of what is giving us a weight, and it should be 15%. The probability X is less than or equal to some weight. Let's call the weight M for Mark is less than 15%. First thing we need to do is standardize it. So it would be the probability of Z is less than or equal to M minus the mean 7.5 over the standard deviation 0.25 equals 0.15. Now look in our table and see what gonna give us 0.15. Now nothing gonna give us 0.15. We know that. We know nothing will give us 0.15.
Minus it from 1.
Very good. We need to minus it from 1. We need to minus it from 1. And if we're, so now we realize then if we're getting X is less than or equal to M and it's giving us less, which rule is this again?
Go again.
Which rule is this? When you have X is less than or equal to M and you're getting 0.15. That means M must be what? Something off there. M must be smaller than the mean.
Right.
And the mean is 7.5. There's only one answer smaller than the mean, you know. We know what
7.240.
Yeah, we know what's the answer, you know, but we want to work it out. So now we know that M is going to be smaller than the mean, just off the basis that we know that this right here is negative. We know M is negative. So really and truly we're saying this is actually 1 minus the probability of, this is now 1 minus the probability of M here, so it's negative. So it's going to become 7.5 minus M over 0.25. And that's equal to the 0.15. So bring this over here and bring that over there. So now we get 0.85 is equal to this part now, phi of 7.5 minus M over 0.25. So now in that case now, all we do is look at which part in the table give us 0.85. So go to the table, 0.85, 0.85. 85 is going to be here, which is 1.04. I'm actually rounding off. It's not 1.04, not quite. So now we can say
it's a 0.85, 0.84. Yeah. So 0.84 is going to give 7995.
0.85, 0.85. Here's 0.85.
Look in the table.
Yeah. In the table, isn't that 1.04?
0.85?
Yeah, 1.04.
0.85. That is 0.88023. You have it down at 9. It said 0.85. Go up the top.
Here is 0.85.
0.85, you said enough?
Yeah, 0.85. As in the probability 0.85.
Oh, okay.
In the table, yeah, in the
That
table.
is 1, right?
Not the 0.85 reading across, no. 0.85 here. So now we're going to equate 7.5 minus m over 0.25 equal to 0.85. We cross multiply. So 0.85 times 0.25, that gives us 0.2125. That's 7.5 minus m. And then we switch them now and say m equals 7.5 minus 0.2125. That's how we get 0. This is going to be 0.28, but because they would have done some rounding off, that's how we're going to get to our 7.24. Going to be option A. You're doing some rounding off.
Okay.
So that's it. Option A. Cool?
Yep.
So have to memorize those formulas and we're good. Now this question here, it says Carlton has a Z-score. They give us the Z-score. That make it well easy. That means we don't have to standardize it. Carlton has a Z-score of 1.74 on his achievement test. Did he score higher than my score in the 9th? It says, did he score higher than my score in the 98th percentile? What was, they can't have 2 question marks. It's either it's a statement so we can answer the next part of the question. What are they doing? I am going to speculate this is a full stop. It has to be. Do you get what I'm saying?
Yeah.
If it's a question, then it would make any sense. It says, did he score higher than my score in the, it has to be a statement so we can answer the next part of the question. So they really need to look over this before they upload it. Big and bold and put it on website and everything. It gotta be proper. So it says, did he score higher than my score in the 98th? What was Carlton's score? So it gave us the Z-score, but remember, what is Z-score? Remember Z, this is where the formula is important, is X minus mu over sigma. Isn't that the formula for Z?
Yeah.
All right. So if this is the formula for Z and they tell us Z is 1.74, now we don't know what the mean is and we don't know what the standard deviation is, but if it's going to be 1.74, already we know Carlton scored higher. How do we know Carlton scored higher? Look what I'm saying. Work out this for me, 50 minus 40 over 4. That's going to give you a positive Z value, don't it?
Minus.
That will give you a positive number, bigger than 1. It's going to give you an answer bigger than 1. Give it 2 point something.
50 minus 40. Minus 40 divided by 4. 50 minus 40 divided by 4, is it?
All right.
No.
All right, look what I'm saying now, though. Look at this now. Now, how can they even give you a score and we don't know the mean? So this part right here, we're going to have to decipher what they're saying.
2.5.
2.5, good. So notice that 2.5 is bigger. So look at this, a z-score of 1.74. We're going to go to the normal table and say, well, where's 1.74? 1.74 is, where's 1.74?
95.9582. No,
Right.
sorry, no.
Okay.
74, 95, 91.
1.74, 95, 91. Is this bigger than 0.98?
95, 91.
Is this bigger than 0.98?
94.
Which
No,
one
it's
is?
not. No, it's not bigger.
No, so that means he actually didn't get higher than him. Now I get what it's saying. So they should have put I see why they put the question mark there, but the wording is bland. The wording is bland. It's not properly worded. I get what they say now. So no, Carlton didn't score higher. Carlton scored lower. Now, even though Carlton scored lower, it says his score was, we cannot determine his score because this question incomplete. It's either C or D. His score was lower. But we don't know what the mean score is, so we cannot determine anything.
Oh my.
We know Z. We don't know X. We don't know mu. We don't know sigma. We cannot determine X if we don't know the mean and sigma. You notice that probably they thought they had connected it to something where they gave us mu and sigma. But this is poorly done. Look at that. From 31 to 32, no connection, nothing. There's no mean, there's no standard deviation. It cannot work out his score. You absolutely cannot. You cannot have an equation with 3 unknowns and find the value of X. We cannot find this score. All right?
Okay.
So that's really poor. So this again, really poor. Well, it's not really an error. What is missing is the mean. They need to give you the mean and the standard deviation. That's what's missing. That's really bad. That's really bad. You should make sure you email the lecturer and email her and send her this and say, what kind of rubbish is this? No, you should tell her what kind of rubbish is this? Because the exam is Wednesday and persons are going to be saying, I can't answer the question that I got hard. When it's them miss out something out of the question. And I can relate because as a teacher, sometimes I'm putting together practice questions, and because it's not graded, I don't check it over. I don't check to make sure no error in it. But if you're gonna put it up for everyone to use, then you have to check it over. You have to. So that's really sad. Now this one says the school wants to allow students with scores in the top 3% in the program. What will be the minimum score required to be admitted into this program? Is this it's a continuation?
Mm-hmm.
Like, what are they talking about? In order to determine, we must need to know the mean first and the standard deviation before we can determine what's the score. We don't know score out of what? Score out of what? That's so poor. And to put this up, you know?
From 31 to
Repeat.
33.
31.
I said from 31 to 33. 33.
Oh no, 31 was fine. 32 off, 33 off. So this well off.
No, there's 3 errors. Go back. Go up to the top.
Oh yes, this one, 29.
Right. 29.
My gosh.
29, 32, 33.
This is so helps. This is supposed. My gosh, they don't even care. All right, now question 34. So it says the records of an Italian shoe manufacturer show 10% are defective. Assuming independence, find the probability of getting 2 defective shoes. So once they tell you this now, right here, we're talking about some binomial distribution. All right? Because notice they give you n. In the first part, n is 12. And they tell us that the probability of shoe being defective is 0.1. That's a success of it being defective.
Right.
Chance of it being not defective is 0.9. So here we need the probability x equal to, so that gonna be 12 choose 2, 0.12 times 0.9 to the 10. Put that in our calculator. Let me bring up the calculator. I really can't believe they did that. Gosh, man.
I don't know, 12 choose 2.
And that's what we get, 0.23.
.23.
Good. Now tell me how we're going to do the second one. It's binomial again, but it says, what are they giving us?
60
So we need to find, very good, the probability.
effective shoes in the batch of 20.
Good, so n equal how much this time?
20.
20, so it's 20 choose 6.
Right.
0.1 to the 6 times 0.9 to the 14.
Right.
Calculator for me. 20 choose 6. 0.1 to the 6.
Okay. Choose 6, close the bracket, times 0.1. Six. Times open bracket 0.9, close the bracket, 14. 8.86, no.
Yeah, that's fine.
Yeah, right. Yeah, that's what I got.
That is, this is a small number. It's actually 0.00867. 1, 2, 3. Yeah. It's 0.00867. That's it.
Okay.
All right. That's
But
it.
never, but where's the multiple choice for this?
No, this was the multiple choice. It's a structured. You would work it out.
Okay.
Yeah. Yeah. So question 35 and 36 again. These are also some more structured. So question 35, it says the owner of a small restaurant is trying to quantify the variation in daily demand for takeout lunches. She has decided to assume that the demand is normally distributed. First of all, she make a bad judgment already. You can't estimate that it's normally distributed. Why? Orders will vary on weekend. Orders will vary on a Friday. Orders during the week can never be normally distributed. They're not gonna get the same. Trust me, that's a bad owner. Can't do that with numbers.
Okay.
But Ali should do that and she just want to do some calculation. She knows on average 100 takeouts are purchased daily. Or she think, better them say she think, but she can't know 100 takeouts purchased. Well, she would know because our cashier would tell her. She knows on average 100 takeouts are purchased daily. So what's the mean? What's the mean? It says, I just underline it.
100.
So the mean is 100. And it says, and that 90% of the time, the daily demand is below 116. What else did they just give us? They just told us that the probability, the amount of lunches, the daily demand is below 116 equals 0.9. Isn't that what they just gave us?
Yeah.
Yeah, that's it. So all we need to do is standardize that now. So for that part, we can standardize it to get the probability of Z is less than 116 minus 100 over the standard deviation equals 0.9. So look in the table for 0.9. 0.9 would be
8159.
81.
0.9. Oh,
9. That's the 0.9 here, 1.2. 1.29. That's the closest one to it.
Yes.
So 1.29. So in other words, we're telling them that this part right here, this value should be 1.29. So we can set up the equation now. So 116 minus 100 is 16. 16 over sigma is 1.29. So find sigma, we interchange them. So 16 over 1.29 equals sigma. So all we do is a little bit of flipping around right here, right? And then that will give us sigma, 16 over 1.29. Put that in our calculator. 16 over 1.29. And we get 12.4. So that's the standard deviation, 12.4. 12.4 lunches per day is the deviation. Now it says the owner of a large restaurant wants to stock enough boxes each day so that the probability of running out of boxes is no higher than 0.05. What is the lowest number of boxes she would stock to achieve this? Just to say?
It's no higher than that. So 0.
So that is what? Probability X is greater than or less than? What should be?
No, less than.
No higher.
Less than 0. No, less than.
Less than or what?
Greater than 0.05.
Less than or equal to 0.05. Right? So we need to find out what N is. Probability X equal N is less than or equal to 0.05. We need to find out what's the least number N can be. So to find out, so with normal distribution, remember this is really X less than or equal to N, less than or equal to 0.05. So as you just said, standardize. So we standardize, that become the probability Z is less than or equal to N minus the mean of 100 over the standard deviation of 12.4 is less than or equal to 0.05. But we can say hold up. Once we see it's right here, we know it should be 1 minus the probability of 1 minus the probability Z is less than or equal to the negative of this. And the negative of this would be 100 minus N over 12.4. That's equal to 0.05. So now flip them. Bring the 0.05 over here. That's equal to the probability Z is less than or equal to 100 minus N over 12.4. We subtract them, we'll get 0.95. And we know 0.95, if you look in the table, 1.96 will correspond to 0.95, don't it?
At 5, yeah, right, because they tell you must always remember that,
Must
right?
always remember that one. There's a other couple that we must remember. So now we're going to set 1.96 equal 100 minus n over 12.4. Finding n now. Cross multiply 1.96 times 12.4 equal 100 minus n. So 1.96 times 12.4, that's 24.30 equal 100 minus n. So we bring over, we get n equal 100 minus 24.3. And we get 75.7. Now, this is the thing now, Charmaine, you never put 75.7. You can't have 0.7 box. You just put any.
Only call 70.76.
No, 75. Leave it at 75. All right. It don't reach 76 yet. Remember what box is? It don't reach it yet. So we're going to just say 75. So that's the least amount you would want to pack. All right.
Okay.
All right. Now this last one here, it says, let me just copy the question to the blank screen.
I didn't do 25 and 26. We did 25?
We didn't do 25? Okay, no problem. We'll go back. All right, let me.
25 and 26.
Okay, great. Let me. You see, this is what I don't like. I don't understand this one so much. I don't know how to copy.
Just delete it.
No, as in I don't know how to copy.
Okay. Oh.
When I'm in Zodo, I know how to copy. I don't know how to do anything.
So just delete the working note that you have down the bottom.
Or delete it?
Yeah.
Okay. All right. Yeah.
Because remember, you're going to send a recording, so just delete.
Okay, okay. I know most persons usually use Edge because it's free, but I rather use a software that I pay for that it is easier to work with. Look at that. Look at the time that we spent to erase. It's less time efficient.
Mm-hmm.
But that's what we get with a free version of something. So let's go ahead and do this. It says a restaurant. Them always a talk about baby and restaurant.
Mm-hmm.
My gosh, man, they can't come with something else. A restaurant provides lunches for office workers in New Kingston. From past data, it was estimated that the probability that an office worker orders curry goat is 1/3. The probability them order curry goat is 1/3. If on a given day there are 90 orders for lunches and chef prepares 40 curry goats, what's the probability there will be more requests for curry goat lunches than can be met? So first thing we realize is that this is a distribution binomially. Look, in one given day, 90. Notice what they said. It was estimated that the probability that an officer orders curry goat is 1/3. So they give us the probability of ordering curry goat. Probability of curry goat, 1/3.
Which is 0.33.
0.33. If on a given day there are 90 orders, n equal 90.
Right.
N equal 90. Then they say, and the chef prepares 40 curry goat lunches. So n is the total, and this time the curry goat equal 40. All right. And they say, what is the probability there will be more requests for curry goats than the curry goat lunches than can be met? So let's call curry goat our variable x. So them tell us that, in other words, the probability of x is 1/3, right? Here, so we have x is 40. This is what we have. And then look at this. We're good enough, we're really good. this is our probability P equal 1/3. So that means the expected value of
Right.
should be equal to n times P, don't it?
Mm-hmm. Why don't you use decimals?
Huh?
Why don't you use decimals instead of the fraction?
Well, the fraction is easy because 90 times 1/3 is 30. 30,
Oh.
yeah. I try to stay away from decimals if it's gonna work out to be exact.
Okay.
All right, so this is the mean. In other words, we're saying that the expected number of curry goats to be ordered is 30. That's the expected number of curry goats, right?
Right.
So it says, what is the probability there will be more requests than curry goat lunches than can be met? What is the probability? So if the expected value, what we're gonna have to do now is, this is what we call binomial approximation to the normal distribution. So first thing we need to do is find out the mean, and then we need to find out the variance. The variance of x would then be n times p times q,
X of Q,
which is
right.
90 times
40.
1
Oh,
over 2 times 2 over 3. That's our variance, NPQ, right?
right.
This works out to be
We
3
get
times 3 is
3.
9. Wouldn't that be Q? If the success is 1/3, then the failure is 2/3. They must add back to be 1.
2/3, right.
Yeah. So now 90/9 is 10, 10 2 is 20. Is that right? The variance of x is 20. That's cool?
Right.
In other words, now once we get the variance, let me erase down here. Once we get the variance now we can write down our normal distribution. So now here's our normal distribution. So our normal distribution now we can write down that x, we change the color. X follows a normal distribution of mean, which is 30, comma, a variance of 20. So the standard deviation will be the square root of 20. Just want to write it in a form that we know our standard deviation. So now we can look at the question. Now it says, what is the probability that there will be more requests for lunches that can be met? And that is when, if the chef do what? If the chef prepare 40 curry goats.
Right.
In other words, they're asking us what's the probability x will be greater than that 40,
Right.
more than can be met.
So it's gonna be x greater than 40.
Exactly. But we already set it up in our form that we need now. We need to standardize it. So the probability z is greater than 40 minus 30 over the square root of 20. So that's going to be 40 minus 30 divided by the square root of 20. That's root 5, 2.23. Probability of z being greater than 2.23. So there's a high chance it's going to be, them need more curry goat. 2.23, I believe, was 0.98 something. If I look back in the table, 2.23.
98, 93. 98, 93.
93, yeah. Knew it was 0.98 something, 2.23. And we had 2 more to do. 20, which ones?
25 and
26. Okay, here we go. All right, just going up. So it says they spell enrollment incorrect. That's bad. So the distribution of enrollment in a class is normally distributed with mean 55 and standard deviation of 5. If a particular observation has a standard score, the standardized score z is -1, what can we conclude? If z is -1, this is what we can conclude. Remember, z is x minus the mean 55 over the standard deviation of 5. So That means that -1 is x minus 55 over 5. We need to find x. Cross multiply. -5 is x minus 55. Add 55 to both sides, so x equals 50. Because 50 minus 55 is -5.
Right.
The value of the observation is 50.
Yeah.
Easy, and that was easy.
Mm-hmm.
Now the last one right here, they give us table. Now they say Abigail takes 3 standardized tests. She scores 600 on all 3 of them. Rank her relative performance on the test from best to worst. My gosh, why they want to do so much work, man? So them say we need to rank her. So this is how we're going to rank her. We're going to rank her using the z-test. So remember, z is x minus mu over sigma.
Right.
So for the first one, it would be 500. Well, let's score 600 minus 500 over standard deviation 80. That is 1.25. 100 over 80, that's 1.25. Check it for me. I think that's so.
0.25.
The second one would be 600 minus 470 over 120. 600 minus 470 is 130. 130 over 120 is 13 over 12. 13 over 12 is, I don't know that decimal. 1.08. All right. Then finally, we'll see that right here we have 560 minus, well, 600 minus 560. 600 minus 560 over 30. 600 minus 560 over 30. That's 1.33. So our best relative performance is the highest one. So the highest is test 3. So should the best on test 3, then should the next best on test 1, then should the next best on test 2.
Right.
So 3, 1, 2. Here it is, option B. Easy question, right?
Yep. Yeah.
That's it. So realize how important it is. So once you know the formulas, then normal distribution is really easy, all right?
Okay, just need to practice.
Just practice over, and I'm going to send you an MCQ tomorrow morning on normal distribution, 10 questions, all right?
Okay.
10 multiple choice questions. The binomial, it's not multiple choice. I have a practice question though for binomial with some structure, and I'll send you those for further practice, all right? And please, Charmaine, just practice, 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 practice with time so that you can finish the test and you feel good. All right.
Yeah. Okay.
All right. So I'll send you the recording in the morning with the documents. All right.
All right. No problem.
All right, so take care.
All right. Thanks much.
All right.